Good morning. Now, today is a Monday, and Saturday I got my bit of paper from the university saying I am now a graduate. I've got a diploma in computer science, believe it or not. Now, that meant I was left with no choice but to go to the pub, and I was not able to do Advent of Code. On Sunday, well, it's the Lord's Day, I simply couldn't be bothered actually. And now I've done day two here on a Monday, don't worry about it too much. Now, what we're going to do is, we'll look at the problem. It's on the wrong bloody screen. So here's the problem. Well, that's not a problem. That's me saying I've done the problem. So, if we go to day two, basically, some elves have some bags with cubes in, whatever the fuck that is all about. And we get some input like this. We get game one, 3 blue, 2 red. Oh god, I misread that quite badly. Semicolon, then another lot of that, and so on. So basically, it's a dice game. They got a bag full of coloured dice. They pick out some dice. Then in part one, um, the question is this a valid game given an amount of dice? So they got like, was it 12 red cubes, 13 green cubes, and 14 green cubes. And in the first part, in the game one, they start by picking out 3 red and 4 red. That's fine. They pick out red and 2 green, so on and so forth. And if we go to an invalid one, such as game 3, they pick out 20 red. Well, 20 is more than 12, so that can't be correct. So let's have a look at my solution for this. So what I've done is I copy pasted too many files. Let me clean this up. Yeet. So what I've done for day two is I've started by writing another Lexa, using Lex again, and Flex even. So this is just a scanner to scan the input. We've got some really boring rules: new line, white space, a number, game, blue, red, green, so on and so forth. All the strings that you see in the input. Now, if I go to part 1.y, this is the parser. So I start by making YY error to print out what's gone wrong, and we'll sort of find the maximum amount of red, green, and blue things you can have. And then let's look at the grammars. Ooh, line 23 is exciting. Won't cover that just yet. A GLR parser, how exciting. So we got our input. Input is just new line, input new line line, or input new line, or a line, or percent empty. It's the same as last time. It's just saying that I want some stuff on a new line, maybe even another line, and if there's a leading, trailing new line or something like that, we'd deal with it and we'd be fine and happy. Um, it's just sometimes, new lines creep into your input. So we start with the first rule. Number colon number. Line num is a toy of YY text. What is that doing? And why do we need it? Look ahead tokens. How exciting. Line num, if we look in our parser.h, is part of the struct that we're using for the current line. And it just temporary, I spelled temporary wrong. A temporary store for the last red number. Now, you might be saying, why can't I just read that in the cube rule where it goes num white space green? Why can't I just have number and a semantic action to put YY text into a temporary variable or something? But because it has to look ahead, because it's ambiguous otherwise, it doesn't know what's going on here, it's going to see a number, it's going to look at these rules, it's going to say, what's going on here? There's white space, what's going on here? It looks ahead again, it's going to be green, red or blue. Now it knows what's going on. YY text, which is the last red token by the scanner, would have been overwritten to green, red or blue at this point. Which means if we put it after, in these rules, in the cube grammar, then it would try to read the string, the integer value of a string that says green, for example. And green doesn't map to a colour very well, does it? So we just get 0 and return 0 for everything, because it fails silently like all good software should do. That's a lie. Please make your software fail verbosely. Thank you. So because of that, we put in this num rule here, and what it does is that when it scans the number, we just store the number temporarily. Is there a way around this? Probably, but this is good enough for now. Now, because it has to have a look ahead, we need a GLR parser for it, because otherwise it goes on about some weird conflicts. So if I delete this line, and then I type make, it's going to give us a warning. It's not giving me a warning, that is bad. I guess we don't need a GLR parser. It gave me conflicts at one point, so I put it there. We don't need one, I lied, I'm very sorry. I'm very sorry, I've only just started reading my compiler textbook, please leave me alone. No, so I guess we can have an LA LR1 parser, which is the default. I've probably said that wrong as well. So anyway, because of the look ahead, we need to make it so it's in direction. So when it reads the number, it turns the number into a value which is stored for later. Now, this here just reads something like 1 space green. Then we got to pick, this is something you've picked out of the bag, and you've picked out a cube, or you've picked out a cube, comma, space, white space, pick. For example, you've picked out 2 cubes, it'd be 1 space green, comma, 1 space blue, for example. So that rule just lets us have like those lines there. Then we've got the next one, which is a picks, because each game has lots of picks. You can either have 1 pick, which is colon picks, or you can have a pick, a semicolon, a white space, then another pick, picks. Oh god, should have named these differently, they're quite confusing. Where you could have multiple rounds of a game where you pick out some cubes, put them back, and you pick them out again, and you put them back, and you pick them out again, then you put them back, so on and so forth. And then we got a line. Line, this is where all the exciting stuff happens. First things first, we need the game ID, we sum those up to get the solution. So we just store that. We also memset the line data, that just stores all the totals for red, green and blue in the game ID. So that's so we don't cock up too much, hopefully. And then we got this here, valid is 1. We got a little bit of debug statements. So if the max red is greater than the maximum red we've actually got, game is invalid, and we'll also print something else. Do the same for green and blue. If it's valid, add to the total the game ID, and we also got a little bit of debug here. So that's part 1. It's excluding the bad explanation from me, not too difficult. Part 2 is similar. We need to parse it the same way, but we need to do something different. We need to find out the least amount of red, green and blue cubes possible and multiply them together. It just so happens that turns out to be the maximum amount we read in the per game. So we just, instead of checking if it's valid, we just multiply those numbers together. Correct output. Now I'm going to do part 3 and maybe day 3 even, and day 4, and maybe even upload them today on a Monday. That's right, you might even get 3 uploads in a day. How exciting. Well, just remember, code for this is on GitHub, so you can have a look at it. I'll remember to put the link in the description, actually. That's a goodbye from me.